Question 6 for part A. There's really two ways of doing this. So I'll try and do both. The way they suggest in the question is to start off, let y equal 2 to the power of x. Then what we can do is, because e and ln will cancel each other out, we can just write 2 to the power of x as e ln 2 to the power of x. The reason that's useful is now we can bring the x down to make it x e to the x ln 2, and this is just a constant. So remember that ln 2 is a constant, which means this is no different from differentiating, say, e to the 3x or e to the 5x. So when we differentiate now, if we differentiate both sides, we get dy by dx equals, just bring the constant down, which is ln 2, and then keep everything else as it is. So now we've differentiated, we can then try to go back to how the question originally looked like. In other words, we can try and simplify everything here a little bit. So we'll leave the ln 2 at the front, but now we can put that x back where it was, which is next the power of 2, and now we can cancel the e and the ln, because we don't really want those. So we get our final answer, which is 2 to the power of x ln 2. Another way of doing that is to use implicit differentiation, which you might have done in class quite recently. In fact, we used that for question 4. So another way of doing this is to write y equals 2 to the power of x, and then if you do ln of both sides, you've got ln y equals ln 2 to the x. Now we can bring the x down. Now we now need to differentiate. We haven't differentiated anything yet, but if we differentiate implicitly both sides, we want to differentiate everything with respect to x. So when we differentiate this with respect to x, differentiate with respect to y first of all, and then we just stick a dy by dx down as usual. As in the previous method on the left hand side, this is just a constant. So remember, when you differentiate x ln 2, it's no different from differentiating 2x or 3x. So when we differentiate the right hand side, we're just left with ln 2. And now we're nearly finished. We just need to get dy by dx on its own. So that equals y ln 2. And don't forget that y actually equals 2 to the power of x. So we can write it like that. And we've finished. In part B, you can see what we start with is similar to what we had in part A. I've written the result from part A at the top here, on the top right. So we know that when we have y equals e to the 2x, when you differentiate, you get 2 to the power of x ln 2. But what we have to differentiate is y equals 2 to the x squared. So it's slightly different from what we had in part A. We need to differentiate because we're looking at the gradient of the curve. Now, to differentiate this, I would definitely use the chain rule, and I would let u equal x squared here. Okay, so using the chain rule, if we differentiate u with respect to x, we get 2x, and y will now be 2 to the power of u. When we do dy by du, differentiating 2 to the power of u is exactly what we did over here. When you differentiate 2 to the power of x, you get 2x ln 2. So when you differentiate 2 to the power of u, we're going to get 2u ln 2. And as I'm sure you know from the chain rule, find dy by dx, you multiply dy by du by dx, and so that will give us 2 to the u ln 2 times by 2 to the x. So if we now replace, don't forget that u was x squared, so this now becomes, let's just put the 2x in front, so we've got 2x times by 2 to the x squared ln 2. Now the question says find the gradient of the curve when the coordinates are the coordinates are 216. So at 216, obviously x equals 2. So we want to find dy by dx when x equals 2. So let's substitute that in. So dy by dx is going to equal 2 times by 2 times by 2 to the 2 squared. A lot of 2's. I've never seen so many 2's before in one equation. Anyway, if we move that up there, dy by dx, let's just sort out all these 2's, shall we? So 2 squared is 4, and then you've got 2 to the power of 4, so that will be a 16. So this here is going to give us 16. We're going to times that by 4, and then we've got to times that by ln 2. So it's 64 ln 2. It doesn't say to leave it exact or as a decimal, so I would just leave it excuse me, leave it exact like that, and I'm sure that's fine.